All right, this is lesson 2.1 and 2.2. This first part is chapter 2.1, solving with addition and subtraction. These are just one-step problems. Addition and subtraction are inverse operations. In order to solve an equation with addition, you must subtract or perform the inverse operation. So our example is x plus 8 equals 9. First of all, anytime you're solving an equation, I'd like for you to draw a line straight down from the equal sign. And what that means is as we're solving, that's where the equal sign should always be, should not move. The other thing I would like you to do is I would like you to isolate your variable. What I mean by that is I want you to put it in a box so we know what we're trying to get by itself. So at the very bottom of this, I should see x equals something. Now, how are we going to get x by itself? Well, here we have a plus 8, and so the inverse of addition is subtraction. So I'm going to do minus 8, and whatever I do on one side, I have to do on the other side. I'm going to erase this equal sign. Okay. So plus 8 minus 8 is 0. So my x comes down here, and 9 minus 8 is 1. So x equals 1. Now, I know a lot of you are probably looking at this equation and saying, yeah, I knew it was 1 before you even started. But I need to show you algebraically how this works. Okay? So a couple things to remember. Addition is the inverse of subtraction and vice versa. And whatever you do on one side, you must do the other. We have to keep the equation balanced. Another way you could have written this, or you might see it solved like this sometime, is like this. So here you can see I did minus 8 and minus 8. I did it on both sides. Well, what's 8 minus 8? 0. 9 minus 8 is 1. So x equals 1. Okay, so it's same thing, just written differently. I would like to see you do it like this, but I just want you to see what it would look like this if you see someone else teach it a different way. So it's going to be the same thing when we have subtraction. We're going to put a box around our variable, and we're going to draw a line down from our equal sign. So then we see, okay, what do we need to get rid of here? We have a minus 10 here. And so the inverse of subtraction is addition. So I'm going to add 10 to both sides. Negative 10 plus 10 is 0. So I bring down my y. My equal sign stays on the line. Negative 8 plus 10 is 2. So y equals 2. So let's check and see if that's right. So if I plug in a 2 for y, is this going to give me the correct solution? Well, what is 2 minus 10? 2 minus 10 is in fact negative 8. So that is the correct solution. Okay, so I'm going to go through these examples because some of these look different, but it's still the same process. Okay, so I'm going to write this over here. Oh, I'll just do it here. All right, so I'm going to put a box around my x. I want you to know that it's very important that this is a positive x. If this is a negative x, then that's actually a two-step problem, which we'll talk about later in a different lesson. Okay, so just know that knowing this is positive is important. Draw my line. So I have a negative 5 here I need to get rid of. So how do I make negative 5 0? I add 5. I do the inverse. So x equals negative 8 plus 5 is negative 3. All right, put a box around my a. Again, it's important that this is positive. Draw your line. This is a 9. Okay, so this is a positive 9. So to make this 0, I need to subtract 9 on both sides. 4 minus 9 is negative 5. So negative 5 equals a. So the reason I put these on here is so you know that the variable can be on either side. It doesn't matter. And you need to know that that is the same as this. Okay, negative 5 equals a is the same as a equals negative 5. All right, I'm going to do this one down here. 15 equals c minus 17. Box my variable, draw my line. I need to get rid of this minus 17. Notice I'm always getting rid of whatever is on the side with the variable. So I don't want to get rid of this 15 because it's already on the other side, which is where I want everything to be. So in order to undo, or the inverse of minus 17 is plus 17. plus 17. Okay, so negative 17 plus 17 is 0. Now you notice I haven't written 0 before because that's unnecessary. Okay, but I just want to show you what that looks like. So that's why I just cross it out instead. I bring down my C equals 15 plus 17, 7 plus 5 is 12, carry the 1, 32. So in other words, that means that 32, right here, 32 minus 17 is 15. All right, 1 plus b equals 12, so I'm going to isolate my b, minus 1, minus 1. Why am I subtracting? Because this is a positive 1. 1 minus 1 is 0, and so b equals 11. Okay, box my m, draw my line. The other reason why I draw a line, and I'm sorry I didn't do that here, the other reason why I draw a line is so, again, I can see the two sides. So where's my variable? My variable's on the right, so that means anything else on the right needs to go left. So negative 4, what's the inverse of minus 4 or negative 4? Plus 4, plus 4. Negative 4 plus 4 is 0. Bring down my m. Equals, what's negative 4 plus 4? 0. Weird, but not weird. Okay, so that means m equals 0. M can equal 0. That is totally fine. That is a perfectly good solution. Okay, so I just don't want you to be afraid if you get an answer that's 0. All right, now moving on to multiplication division. Again, these are also inverse operations, so we really do it the same as we did addition and subtraction. Okay, now this time when I'm boxing my variable, I only want to box the variable, not the coefficient. Okay, remember this negative 4 is a coefficient. Draw my line. Now you want to ask yourself, okay, what operation is this? You see the negative sign, but this is not subtraction. This 4 is not being subtracted from anything. Okay, so what's actually happening here is that this negative 4 is being multiplied by x. So if this is being multiplied, then the inverse of that is division. And I need to divide by exactly what the coefficient is. So what is negative 4 divided by negative 4? It's 1. That's exactly what I want. So previously I wanted to get 0, but now I want a 1 because I don't want my variable to go away. Okay, if I get 0, then I don't have any x's at all left, but I need the x there. So negative 4 over negative 4 is 1, so I have 1x equals negative 6. Now again, this 1 is not necessary, so you could just say x equals negative 6. This is how I would like to see it on your paper. I don't want to see the 1 as your final answer, not the 1x. Okay, again, we could check this. Negative 4 parentheses negative 6 is in fact 24 because a negative times a negative is a positive. So that's when you have multiplication, you do the inverse division. Okay, now let's look at when we have division and we need to do the inverse, which is multiplication. Okay, so this is a over 7 equals 3. Or in other words, a divided by 7 equals 3. So if I'm dividing by 7, then the inverse of that is going to be multiplication. So I'm going to multiply this by 7. Now, and then I'm also going to do that here, times 7. Now let me explain what this is here. This is the same as 7 over 1 times a over 7, which is 7a over 7. And 7 divided by 7 is 1, so it is the same as 1a. Okay, you can kind of think about it. This is the numerator, this is the denominator. 7 over 7 is 1. So that's how we're left with a. So I'll cross those out. Again, that's not 0, that's 1. A equals 21. Now, with that, I also want you to understand that a over 7 is the same as 1/7 a. Okay, these are equivalent. You need to know that. If I had 2a over 7, then that would be the same as 2/7 a. Okay, and we'll talk about how to solve with fractions like this in our examples coming up next. All right, so here's some examples. Again, I put the variable on the right side just so you know that that's okay. Box my x, draw my line. What is this operation? This is multiplication, so I'm going to divide by 2. Divide by 2. Negative 8 divided by 2 is negative 4 equals x, or x equals negative 4. Same thing. x. Okay. All right, here I have 1/3 g equals -5. 1/3 g equals -5. So this time I have the fraction as the coefficient. Instead of the g being in the denominator, I just have the fraction as a coefficient. So what is this operation here? This is 1/3 times g. 1/3 times g. So if this is multiplication, what's the inverse of multiplication? It's division. Well, how do I divide by 1/3? If I'm dividing by 1/3, isn't that the same as multiplying by 3/1? Remember, division, dividing by 1/3 is the same as multiplying by the reciprocal. Okay, multiplying by the reciprocal. So that's what I'm going to do here. I'm going to multiply by the reciprocal. Same thing here, times 3/1. 3/1 is the same as 3. So if you just write times 3, that would be the same thing. So 3/1 times 1/3 is 1. So I have g equals -15. Let me go back to this page. Okay, you see here how we multiplied by 7? Which is the same as this is the same as 1/7a. And like in this one, I just told you that if it's 1/3 g, you multiply by 3/1. That's exactly what we did here. If it was 1/7 a, we multiplied by 7, or 7/1. All right, number 8. -3/4 d equals 4. Again, I have a fraction as the coefficient. That means this is being multiplied. So to undo multiplication, I divide, but if it's a fraction, I need to multiply by the reciprocal, making sure you keep the sign. So I'm going to multiply this by -4/3. So this was a negative fraction. This stays a negative fraction. Multiply this also by -4/3. So this cancels to be a 1. So d equals, all right, let me do this math over here. 4 times -4/3. Remember, 4 is the same as 4/1. 4 times -4 is -16. 1 times 3 is 3. How many times does 3, let's see, can I simplify this? No, because the only factor is 3, and 3 doesn't go into 16 evenly, and I don't want a mixed number. I want an improper fraction. So that's my answer. D equals -16/3. When you're writing your answer, you might want to write it like this. Okay, that's also the same thing, fraction. All right, last one, including some decimals. So I have my f here that I'm trying to isolate. Also use some different variables so you know it's not always x. This is multiplication, so I'm going to divide by 5, divide by 5. So I need to divide. All right, 1.5 divided by 5. Bring my decimal up. How many times does 5 go into 15? 3. So the answer f equals 0.3 or 3/10. All right, so that is how you solve one-step equations with any operation, adding, subtracting, multiplying, or dividing. Make sure you look at your practice problems. I would encourage you to go back through some of these problems I did in the notes because we will be doing the practice problems in class. So you don't need to do the practice problems at home, but you need to understand these examples that I've done. So if you need to, go back, write them on a separate sheet of paper, and rework them and see if you understand what I did. And if you don't, you need to write your questions down and come with those to class. See you then.